everyone. Today we'll be hearing from Oscar Roche as he speaks on the topic of real continuous improvement. Oscar believes in two things that drive his endeavors in building capability. First, people must have trust in his intent. And second, nothing is more effective and liberating than saying, I'm not sure. Then learning by doing. As director of the Australian, New Zealand, and Southeast Asian TWI Institute Global Partnership, Oscar is mindful of these two things daily. He frequently quotes a manager he's met who said, "The more I know, the more I realize I don't know." He feels that as long as he maintains his mindset, I'm sorry, I'm going to start over. My daggone phone started ringing. Thought I had it turned down enough. You may not be able to hear it through it, but I did. That was kind of distracting. So should we just edit this out and get going again?
Oh, no, that was fine.
Okay. All right, you ready, Oscar?
I'm waiting, Jim. I'm waiting, mate.
All right. Hello, everyone. Today we'll be, I'm going to start over again.
So just, Jim, just hang on a minute. The title of like you said, it's on continuous improvement. That's actually the title. Making continuous improvement more real. So I don't know if you want to say that.
Okay, you want to retype that? Okay. We actually have a teleprompter, so.
Ah, okay, right.
He speaks on, what was the title again? I guess we're here.
Making continuous improvement more real.
Okay.
There, is that better?
Yeah.
Okay.
I'm assuming it's still running.
Yeah, we're still running.
Okay. All right. Hello, everyone. Today we'll be hearing from Oscar Roche as he speaks on making continuous improvement more real. Oscar believes in two things that drives his endeavors in building capability. First, people must have trust in his intent. And second, nothing is more effective and liberating than saying, I'm not sure, than learning by doing. As director of the Australian, New Zealand, and Southeast Asian TWI Institute Global Partnership, Oscar is mindful of these two things daily. He frequently quotes a manager he's met who said, "The more I know, the more I realize I don't know." He feels that as long as he maintains that mindset, he can be of service to others. Finally, he loves Mark Rosenthal's quote of, "Teach to the extent their knowledge threshold, not demonstrate yours." So thank you, Oscar, for sharing with us today. And for now, I'll hand it over to you.
Great, thanks, Jim. I'll just start by sharing my screen and putting the PowerPoint into presentation mode. So again, yeah, thanks, Jim. Thanks for that introduction. And I appreciate the opportunity through Lean Frontiers for doing this presentation. They've been very helpful to me over the years. Thank you. So, making continuous improvement real. Does Mr. Isao Kato's 5-step-up model make lean make more sense? We believe so, and I certainly believe so through application. And I'd really like you to decide through what you hear in this and then maybe your application afterwards. A little bit of background on that 5-step-up model and where we learned about that. You can see a group of 10 or 11 people there at the bottom of the slide. That was this time last year. We spent a week in Japan, 4 days of which was with Mr. Kato, who you can see in the middle there, at the lower side. He was 82, he's 83 years old now. Mr. Kato was the HR advisor to Ono during the 50s, 60s, and 70s, and early part of the 80s. And really our time with him was really fantastic. And I guess those opportunities are running out as time goes on. It was terrific to hear firsthand what they went through and what really contributed to what we saw and gave the name Lean to in the 80s and 90s. So let's get started. And as I said, this is my explaining the 5-step-up model, and then Jim and I will have a conversation towards the end. It's really about you forming your own opinion of what you think of the potential of this model to make continuous improvement more real. All right, let's have a look at the model itself. So in every work environment, in every operation and every business, there is work. Whether it's standardized or not, it's irrelevant. There is work in every work environment. In this model, we start off with developing work standards. I'll expand on that in more detail. But we start off with establishing work standards. The outcome we want from our work standards is to be able to define good or define normal. Then, through standardization, we problem solve abnormal, we build adherence to work standards. And if we do that for long enough, we will have efficient standardized work, which is production at tact. In other words, production at the pace of the orders coming in from the customer. The work is sequenced precisely and we have just enough WIP. So that essentially there's the model. I just want to go through some definitions, if that's okay, because one of the things that I've always struggled with over the years, in a lot of things in Lean, but particularly with standardization, is the different words that are used, or the same words that are used, people have different interpretations. So what I'm going to go through now, I'm not saying is right or wrong, but it's clear, we need to clarify the definitions of the words that we've used that I'll be using in this presentation and within the model that we got from Mr. Cato. So the first thing is the definition of a work standard. A work standard is a foundational thing that describes normal. And the purpose of that is so an abnormal or a normal abnormal judgment can be made. So a work standard is a noun, it's a foundational thing. Standardization, on the left side, is a verb. Standardization is what we will do along the way. So things like get pulled in like 5S, Visual Workplace, Kanban, Hojunka, many other things, the TWI skills of job instruction, job relations, job methods. These are all the things that get pulled in as we standardize or go through the process of standardization. So standardization is a verb, it's what we do along the way. And then standardized work, or efficient standardized work, but really the word standardized I'm focusing on there, describes the work now, or then, I should say probably, as a result of the doing. So standardized work, standardized is an adjective, it describes the work as a consequence of standardization, being the doing work. And at that point, our work happens at the pace required by the customer. There's a pull system. It's sequenced optimally to give the highest possible productivity with the lowest cost and at the required pace, and with nothing left over at any point. In other words, WIP's extremely well managed. So there is some key definitions that will be important in our discussion in the next 30 minutes or so. Excuse me. All right, so let's have a look at the 5 step-ups. Step up 1, as I've indicated, is development of our work standards, and it's in step up 1 where normal is clearly defined. Normal is clearly defined. It's done in at 3 levels. Our work standard for our output, work standard for the machine which produces the output, and then the work standard for the person who interacts with the machine that produces the output. And I'll expand on that flow and the development and the application flow in about 10 slides or so. But essentially, step up 1 is about developing work standards so that normal is clearly defined. And just to add to that, a machine or person work standard has a time component, which is a normal time to do each element of the work. The reason that that's important is because it sets a foundation for the sequencing optimally and also developing, being able to produce at tact. So we capture that that time component right at the start. Step up 2, once we have our, once we've established or defined normal in step up 1, step up 2 is a heavy emphasis on training, a very heavy emphasis on training to the work standard. We're starting to balance work to tact. Work sequencing has started. We start organising sufficient WIP for just in time, but not excess. Charts and visual aids are used, and a means by which rapid determination of normal, abnormal is being developed. So that's step up 2. Step up 3, we have our means by which rapid determination and alerting of normal, abnormal is in place. We have reoccurrence prevention. In other words, our problem solving involves quite efficient root cause analysis, where we're reducing the risk of root cause to an acceptable level. We start working on the standardization of incidental tasks. In other words, the standardization philosophies that we've applied to our production process or our delivery of our service, we now start applying to something like material ordering or the scheduling of production or perhaps preventative maintenance, those type of things. And then we're also in step up 3 working on the leveling of work with consideration to volume and workload changes. So in other words, what we're saying there, if orders are coming in not in a straight line, varying, we're starting to level workload with consideration to the volume and workload changes based on the orders that come into the system. And what we're really saying there is at step up 3, what we're doing what we call gap closing. So gap closing is where we have normal, we're going along at normal, and then something happens and we produce abnormal. So we've created that gap. So really step up 3, we're getting very, very good at gap closing and eliminating the risk of further gaps. Step up 4 is where it ramps up. We're starting to strive now for new levels of performance. So we call that gap setting. So we have normal, and gap setting is when we raise the bar of normal, which gives us a gap. So we've set a gap, we now have to close it. So this is where the genuine continuous improvement starts. Gap closing is not genuine continuous improvement. Gap setting is genuine continuous improvement. So there we're starting to strive for new levels of performance through gap setting. So we're getting to the sharp end of the stick. We have very low cycle and changeover times, multi-skilling of people, and what we will discuss towards the end of this webinar of this presentation, genuine continuous improvement. And then at step up 5, what Cato wrote for that was, we have rigorous system of checks and balances ensuring an effective rapid response to abnormal and ensuring genuine continuous improvement. So essentially this rigorous system takes you back to step up 1, where there is a gap that needs to be closed, because that will still happen in the real world. We ensure an effective rapid response. That may take us back to step up 1. What that's in that particular area of the plant or the operation. What we're saying that a rigorous system will ensure we go step up 1, 2, 3, 4 very, very quickly. And genuine continuous improvement is what we're going to discuss a little bit more at the end of this presentation. One refreshing thing, because while we were going through this model, I was thinking to myself, and no offense to anyone who's watching this presentation, I was thinking, gee, most of the clients I work with, they're sort of done a bit of step up 1, but maybe not that well. They're at step up 2 level. Some of them might be step up 3. And I'm thinking, wow, step up 4 and step up 5 for myself and others is a bit of a dream. And Cato said this, not every organization can and needs to get to step up 5. But substantial benefit will be gained by adopting the philosophies of standardization to take you as far as is needed. I've added in the commercially, he didn't say that. He just said take you as far as is needed. And I think that's an important point. We shouldn't get lost. This is not a rollout plan. We need to get to step up 5. What he was saying here is the philosophies that are contained within each of the step ups, every organization can get value from those. We don't need to all get to step up 5. And the other interesting thing he said very few Toyota plants are at step up 5, in his view. Majority are at step up 4. All are operating at step up 3. Quite a lot at step up 4, but very, very few are genuinely at step up 5. We found that quite interesting and quite refreshing. All right, let's have a little bit more look in detail at step up 1. And the reason I want to do this is because I think it's overlooked. My learning since the last 12 months, I've been lucky to be able to apply to learn by doing myself in two dairy environments and 1 winery. And I've got a lot of value from that. And I suspected it at the time a year ago when he gave us this model, but I've really had it confirmed to me through my own learning, is that we don't do step up 1 well. We generally start to skip straight to step up 2. In other words, we start training people without considering step up 1 and defining normal. So let's have a little bit more look in detail at step up 1. So as I've said already, step up 1 is about clearly defining normal. Now, work standards are not a basis for finding fault. I think that's an important point to understand. Work standards are not a basis for finding fault. And then Cato, John Shook has quoted Mr. Cato as saying the following for many years: before you can begin with standardized work, you must clarify your work standards. And I read that statement from John Shook a little bit after coming back from Japan, and it wasn't really clear in my mind why he said it. I suspected he had good reason for saying it, but it wasn't clear to me why he said it. It's become, at the time, and now it has become super clear. So let's have a look at why step up 1 is important. So, as I said, every organisation has work, but if we don't have our work standards, if we haven't defined normal, this quote came from the Lean Thinker in December last year. If we don't have a clear expectation of what good looks like, then our definition of not good is subjective and varies depending on who, what, and when things are being looked at. And I read that, and at that stage I'd started to do work at one of the wineries with this model, Step Up 1, and that really resonated with me. In fact, I stuck it in my folder, so when I was walking around the winery and working with the subject guys, I opened my folder several times and pointed them at that little statement. And I got a lot of value from that, and so did they. If we don't have a clear expectation of what good looks like, then our definition of not good is subjective and varies depending on who, what, and when things are being looked at. So what type of problems might this create? In a live audience, I always ask that question, and there's never a shortage of answers. Arguments, people going down the track of their biases, and all those sort of stuff. So when that's happening, then remember in step up 2 and 3, we're problem solving abnormal and building adherence to work standards. Pretty hard. It makes it much harder to problem solve abnormal if first we've got to sort through specialist opinions and feelings. And it's pretty hard to build adherence to work standards if first we've got to sort through specialist opinions and feelings. So any of you who have worked or work now in a shift environment, the build adherence to work standards is, I think, very recognisable. The classic situation that we hear it all the time is, the day shift is running the machine, and and the output appears normal. Afternoon shift come in, and they say, "Oh, day shift, why have they got the machine set like this?" And they immediately alter the settings on the machine. This happens when our expectation of what good looks like is subjective. Very familiar to me. The problem-solving abnormal had a really good example of this about 2 months ago. I was at a beverage producer, and I was talking to the shift supervisor who we're doing some of this work with, and the QA guy walks in, and the particular line he's referring to is a beverage filling line that has a filling nozzle that sanitizer is squirted on every 5 minutes. So every 5 minutes it gets a squirt of sanitizer onto the filling nozzle. The QA guy walks in and said to the supervisor, he said that spray nozzle is not working properly. And the supervisor said, "Oh, what do you mean? What do you mean by that?" And the QA guy said, "Well, it's just coming out as a bit of a jet, a bit of a dribble almost." And the supervisor said, "Well, it's been like that for a long time, probably a couple of years." And the QA guy, "Well, it shouldn't be like that." And the supervisor said, "Well, so what should it look like?" "Well, it should be," and this conversation then went on for about 8 minutes, I reckon. I looked at my watch because I knew what was going to happen, and I thought I'll time this out of interest. So it went for about 8 minutes. The QA guy walked away, and I said to the supervisor, "What just happened?" And I happened to have my folder open that I was just talking about, and he pointed to the statement in that folder, and that was fantastic because he recognised it straight away. And I said, "What are you going to do now?" And he said, "I'm going to go down and see the maintenance manager." And I said, "What do you think will happen?" And he said, "Oh, we'll have the same conversation." Again, "How long will that take?" And he said, "Oh, about 10 minutes. I said, interesting. So there's 18 minutes. And then I said, "What will you do then?" And he said, I'll probably need to go and see the production manager and explain the situation to them. We'll need to get a decision on what we're going to do." And I said, "How long do you think that conversation will take?" He said, "Oh, probably about 10 minutes. So I said, "Well, there's 28. So 28 minutes of absolutely no value add time, a wasted conversation. There was no value add in any of the conversation. The conversation wouldn't have been had normal been defined for that spray nozzle pattern. And once I've now become very conscious of that and those conversations, even within our own organisation and in others, and it frightens me how often I hear conversations like that add no value to the organisation, are a complete waste of time, and can be eliminated if we first establish normal. So what does it look like? If we do have a clear expectation of what good looks like, then our definition of not good is objective and the same, no matter who, what, and when things are being looked at. So if we do have our work standards in place, then we're in the green situation, and problem solving abnormal and building adherence to work standards is much easier because there's no sorting through good or not good opinions. Not only is it easier, well, I guess the two go hand in hand, it's easier and it's quicker. So if we have clear expectation of good or normal, then problem solving abnormal and building adherence to work standards becomes much easier, much less debates, and much quicker. We'll now have a look at the building of the sequence of these work standards. And remember, we're all leading towards this genuine continuous improvement. The point I'm making, trying to transfer here, is the importance of doing this foundational stuff first. So let's have a look at how we build our work standards, how we use them, and then I'm going to add in another why that they are important, as to why they're important. So we build this way, from left to right, from their output, it's here, to our machine, to our people. If we're in a service environment, then we're not considering this one. We still build the machine one. We're still building left to right. So the output work standard is pulled by the customer, and the customer could be internal, could be external. The normal in the output is defined by the customer. And for now, we're going to say we're just going to concern ourselves with the quality aspect of being in spec. So we define normal for the output. Oops, sorry, I've clicked too early. My apologies, let me unclick. We define normal for the output. Once we've defined normal for the output, we ask ourselves, what are the variables in the machine? What are the variables in the machine that are going to contribute to getting normal in the output? And we determine those variables, and then we define normal for those variables. Then we say, what's normal for what does the person need to do to set the machine to normal, and what's normal for the sequence they do it in and the time it takes. So we build this way. We start with the customer, then we determine normal for the output. From that, we understand the variables in the machine and determine normal for them. Then from that, we understand the sequence and the time it takes for the person to set the machine to normal. So the hypothesis we have is that if the person does normal, the machine will be set to normal, the output will be normal, and the customer will be happy. So we build this way, and we do this way, as I just illustrated. The person sets up the machine through normal delivers the output keeps the customer happy. Now, I've only considered the in-spec element so far. There's a second element, or two more elements. The customer wants it in-spec on time, and we want it internally, the organisation, at lowest cost. So because of the on-time lowest cost is why we introduce time and sequence elements, as I said earlier, into our work standards at this point. So the time it takes and the sequencing is important, because if we're going to meet TACT and deliver at lowest cost, then we need to establish a base normal from which we can problem solve. So just another why, again, you're familiar with that, what's in that green box. If we do have a clear expectation of what good looks like, then our definition of not good is objective and the same. So that's very helpful. I think this really ties in, what I've just shown you, and that statement really ties in with what I read in the DNA of the decoding of the DNA article by Spear and Bowen in 1999. And Jim was the one who referred me to this, so thanks, Jim. TPS creates a community of scientists. Whenever Toyota creates a specification, it is establishing sets of hypotheses that can be tested. So you think of that statement, and you think of Cato's statement about without work standards, there will be no standardized work. One and one's starting to make two. In other words, if we had our red statement and we haven't determined normal, then this would be pretty hard to be an efficient community of scientists. But if we've determined normal, defined normal, and we're saying that it's all about problem solving abnormal and building adherence to work standards, then this TPS creates a community of scientists thing sort of makes sense. You can see how it's coming together. I think that statement there sort of is part of joining the dots, the one there and the yellow on the right. So thanks, Jim, for alerting me to that. It sort of helped it make sense in my mind, and I can see it starting to happen in our applications with the two dairies in the winery. All right, let me show you the application of these, development of these work standards very quickly. I'm just going to run for about a minute a video of the production line, the cask line at the winery. So it's a cask filling line. You'll see bags being filled. You'll see the bags sliding down into the boxes. You'll see the boxes getting closed and then coming out the other end with the bag in the inner all sealed up. So this will go for about 40 seconds, I think it is. So you can see the bag coming down, being filled into the box. The box getting glued and closed. It's getting compressed there and spat out the end. And off down the line. So that was the first point of application of these work standards. So just to illustrate a part of a output work standard, here you can see the element we're referring to on the output. That cask you just saw was the top and the bottom of the inner. The inner is the cask. The quality point description, the normal is zero overhang, both ends. So normal is zero overhang at both ends. The machine elements that impact that normal is the inner erector suction caps, the location on the inner, pardon me, and the inner erector half moon. So what we're saying is that the settings or the normal for these two elements of the machine is what will impact normal in the product. So the normal position for the inner erector suction caps is 30 to 40 millimeters in from the edge. And for the half moon, it's directly in line with the inner crease. There's the half moon, you can see it sitting there. So we determine normal in the output, then we look at the machine and say, well, what impacts normal, what's normal in the machine that will drive normal in the output standard. Then we develop the work standard for the person. Now, here, this is quite lengthy. I'm not expecting you to be able to read this full document, but you can see this is the process they go through to set up that whole machine. The sequence of process steps is listed, and so is the time to do each. So the sequencing and time is captured in our people work standard. 9 and 10 here, over here, is what we were just referring to in the machine. Just one point. Sorry. From an operator point of view, pretty hard to do this measurement. So, but we have defined normal, but it's not easy for them to see it and easy for them to see it quickly. So part of step up 2, an important part of step up 2 is developing systems or ways of making abnormal or normal easy to see. For example, a visual device might be included there. I've got a really good example they're developing at the moment on another bit of kit that really well illustrates this point. I haven't got time to go into that detail now. Sorry. All right, so that brings us to an alternative view of value and waste that I would like you to consider. So as I said in step up 1, normal is very objective. The outcome of step up 1 is normal for the product, the machine, and the person is very objective, and it's driven by the customer. It's pulled by the customer, remember, but it's very objective. Normal is clearly defined. And in step up 2 and 3, in both of these, we build adherence to work standards and we problem solve abnormal. So remember that if we've gone to the customer and defined normal, that is that defines value. And what we previously said, or what we've always said in Lean, it's about getting value to flow. I think that getting value to flow gets a bit lost. So here's an alternative view. And we're still applying, remember, we're applying PDCA in problem solving abnormal and building adherence to work standards. But I think there's an important question we can ask. And that question is, what is impeding the flow of normal? I think that's a little bit more meaningful and a little bit easier to see than what's impeding the flow, or how do we get value to flow, which tends to be the question we've asked. If we've defined normal at these 3 levels, if you like, then if we ask ourselves the question, what is impeding the flow of normal, and apply PDCA to that, then what will happen, and I know it happens because I've seen it happen, is waste gets removed. So rather than how do we get value to flow, what if we ask the question, what is impeding the flow of normal? I think there's a lot of potential in that. And what if you apply PDCA to that question, waste will just get removed. It's as simple as that. We don't need to focus on waste removal. If we focus on the question and apply PDCA, waste will get removed. That's what I'm seeing happening more and more as we apply this model in these 3 sites. All right, a quick review. A quick review is that we apply step up 1, 2 and 3. Step up 1 is about clearly defining normal. Step up 2 and 3, at this point of work, is actually standardized. It's at tact, it's sequenced, WIP is okay. It may not be as efficient as it can be or needs to be, but it is standardized and it's stable. We talked about gap closing at step up 3. Then step up 4 and 5, we're striving for new levels of performance with gap setting. Remember, I said we're getting to the sharp end, very low cycle up times, but I did state we're talking about genuine continuous improvement at this point. And in the rigorous system of checks and balances at step up 5, again, Cato quoted, ensuring genuine continuous improvement. So that's what I want to look at now. We're going to bring Jim back into it in a second. But let's have a look at this statement of genuine continuous improvement. So I'm just going to unshare my screen, and Jim's going to reappear if all goes according to plan. Well done. Thanks, Skylar. So Jim, you and I have had quite a lot of conversations over the last probably 3 or 4 years about this genuine continuous improvement. So can you tell us a little bit, what's the thinking and the behaviours that exist behind what you see with genuine continuous improvement, and can you give us some examples of the application of these behaviours?
Yeah, I think so. And I'd start off with a couple aspects of it come together. One is, if you think about the little Toyota house, the TPS house that they draw up very commonly, what's always on the foundation of it is standard work in some form. And as you go through, there's kind of 3 aspects: the product, the output, the machines and process and so forth, and the people. So in a sense, the reason for that is to create stability, because the rest of the house doesn't function very well without that baseline stability. And that's exactly what you're going through, from those 3 aspects, is you got that stability you have to put in place. Otherwise, all these, in a way, higher level items just aren't going to be stable. Or if you want to take it into a processor, like on a line, for example, say like when you view the breakout I did, I talked about lean process design. Well, most people aren't coming anew, they're coming with existing processes. So they must go through the process you talked through in order to reach that stability. Even if you added in a new machine, and let's say you design it from a lean perspective, great and everything feeding up to that standpoint, if it isn't stable, even though that machine may be a good machine, it may be a stable machine, that'll create that machine to be unstable in a sense, because what's feeding into it is unstable. Just like your supply base. If you can't get regular, either good quality or regular deliveries from your supply chain, even though you may be, stable within your walls, you won't be able to function in a stable manner.
Yeah, so I agree. And I think one of the things that's really overlooked in achieving that stability, I think we skip step up 1 and go to step up 2 and 3.
Yeah.
I don't think we focus enough on step up one, which will really give us this really robust foundation for getting stability.
Yeah. Because you aren't really going to be able to do continuous improvement until you have that stability. Even if you think of the kind of improvement stairs, which relates to TWI, right? Job destruction creates this stability,
Yes.
standpoint. And only then, just from that, process and people and training standpoint, you have to have that stability before you can do the JM, to
Yes.
step it up to make that improvement. And then you need to go back and reevaluate your job instruction again to make sure that's stable again. And only when you do that do you get the continual slope up. But most people don't do that. They make the improvement, we'll say JM, they don't really stabilize it, so it degrades. So you may go up a little again. So you're either flat, falling, or at best, a slight slope up. Not the trajectory that you see in this case, for example, like Toyota, to Mr. Cotto's point on doing that. You have to get that in place in order to make the foundation stable to truly get into the, as you said, genuine continuous improvement.
Yeah, so tell us a little bit about that, Jim, genuine continuous improvement, because I know, one of the things I've learned through doing this is I'm nowhere near that. I'm very much operating at the step 1, 2, and 3, even with our own business. I realize that.
Yeah.
So tell us a bit about this genuine continuous improvement.
I think one is, and this goes many years back. This is really kind of the thing that eventually led me to rediscover TWI, is we would put reconfigure our plant, from an overall machine, process, fixturing, a lot of things had, I'll say, good design standpoint. But all these more fundamental things like you're talking about, just because we weren't aware of it, we weren't doing. So even though we had good design, good fixtures, good tooling, all these other things weren't in place at a more foundational level. So as soon as one process fluttered, especially since you're in a flow or one-piece flow standpoint, that quickly rolls through the rest of the overarching process. So we could never get as stable as what I would witness at, in this case, a Toyota plant or an Ison Seiki plant, a Toyota Group company that I had worked for. That stability, that continuous stable output to takt time. So it was one, getting that stability of a lot of companies don't do that, of what their process or what their output should be. I mean, even by their scheduling, they may vary their output day to day and hour to hour. The other thing is just their process, and then they get in flow, so they're coupled together. And it's just that multiplier effect, right? Even if the other ones have a high stability, just the multiple of the one in there at a lower stability messes up the whole thing. And then on top of that comes in the people being able to, like you were talking about, one shift to the next shift. That's where a lot of the job instruction comes in as a stabilization mechanism to get there. And that's just to get to the line to get to a consistent output. So the continuous improvement or genuine continuous improvement, which is actual productivity improvements. The other stuff you talk about is just stabilization improvements.
Yeah, that's right.
Necessarily productivity, it's just getting stable. So you can't really get to that true productivity improvement, genuine continuous improvement, until you reach that threshold that you're talking about. Now, it's very basic, but it's extraordinarily critical to be successful.
And hard.
And hard,
Well,
yes.
I mean, I think one of the things we forget is that, and Mr. Cato gave us a timeline of their work over when they started this, and it was 1952. His timeline started in 1952, not 1982. And we sort of discovered lean in 1985 or whatever, 1952. So, I mean, I think one important point is we need to get better at it, because no company has 30 years anymore to develop that sort of stuff. That's one of the realities. And I think, that's not what the point of this conversation is about. But just, this genuine, let's just assume that people have got to that green line that I showed, and they are able now to genuinely continuously improve. What does that look like, Jim?
I could say, it could come in a whole variety of areas. And that's also, I'll just add this in there just so I don't forget. And that's where the methods and processes of TWI and even Kata help you with that as well, because it gets you to think systematically and rationally as you evaluate. So it really comes in evaluating your your processes, assuming they're even now, they're stable. So what
Yeah,
can
let's
we
assume
do?
they are.
Yeah, we'll assume they're stable. So what can we do to make those things more effective? One could be as simple as this. What could we do so maybe the operator didn't have to spend as long loading and unloading each machine?
Yeah, right.
What is it we can do so we don't build up as much inventory overall, so we could do reduce our overall inventory, which in turn reduces our lead time? What are things we could do in order to improve our changeover, in order so we can change over quicker, so we can increase our mix run based on that and so forth? But unless you have stability in place,
Yeah.
you're going to do that stuff, but you're not going to ultimately reap the reward, which is ultimately the productivity improvement, which is ultimately the financial improvement that you want to get out of it.
I remember you telling me about stuff you did when you were, was it one of the mower companies? Was it Victor Mowers or someone?
Briggs and Stratton.
Briggs and Stratton.
Yeah, they make
So I
small
remember you,
engines in the mowers.
yeah, small engine, Briggs and Stratton, small engines. I remember you telling me about some of the stuff that you did at that, where you were at this genuine continuous improvement point there. Can you give us an example there, an example of what you did there that would slot into this genuine continuous improvement?
Yeah, one was and this was a spin-off of one-piece flow. I mean, that was our overarching design parameter was one-piece flow. Whether it was taking the old equipment that we had, new equipment, some hybrid in between improvement. But one thing we came up with as a design parameter was how do we design the line so we could have a one-armed person operate it? So what that means is obviously the loading into the fixture must be good and easy to do. You've heard of chucku lines.
Yeah.
The rejecting of the previous part must be in place so he can come in with one arm. I'm assuming a part small enough you only need one hand by weight, but you can put the part in. You don't have to move very far. Pick up the next part, which means you need that spacing close. And also, two, you could go and you could actually touch the machine on the direction you're going to the next process anyway.
Yeah,
that also means we have to put safety protocols in place, either whether it's hard metal to block the fixture, or a cutter, or light screens, or things like that. We had to put that stuff in place. We had to put a paddle that they can start. We had to have approved by our safety department. And then we also wanted them to walk as little as possible to get there. So another example we did in the case of one machining line, we had lathes. Well, of course, lathes are naturally long and actually in the wrong orientation. So you got this long machine you got to walk by. Well, what countermeasure we decided to do for that was we stuck the two lathes at the end of the line. So 3/4 of the length of that machine, they never walk by.
Yeah,
so some things, but the one-arm person.
I love that analogy. I love that thinking.
To improve many items.
Yeah, I love that thinking. What I really like about that thinking, it's a bit of a, that to me that's the word, that one-arm thinking underlines the word genuine, because it's innovation. And to use the Toyota Carter type thinking, scientific thinking, you've created you've put a condition that's really quite out there, and that's going to force you to innovate and adapt. Yeah. I really love that. I think that's a terrific example of what, if we're going to be serious about this, that's what genuine continuous improvement is about. It's going to force you to think completely differently.
Yeah, and the thing that brought it to us wasn't like, because we were trying to do this lean, and what indirectly it was, it's, we were zoning based on tack time, what the operators would run in. Well, yes. if we couldn't design things, and ideally that came down to, how could we get a one-armed person to do this? That means there was more variation in loading and unloading between shifts, between operators, between, beginning the shift and into the shift. So we were just saying, what can we do in order to get this consistent loading and unloading time? Then obviously that makes the whole manning of the line, depending on our tack time, much easier to do. We know we could, and if we had to reman because our tack time changed, we could very quickly calculate how many people can run and can they do it successfully.
Yeah.
And can people be comfortable?
And that I really like about that is that introducing that paradigm shift, the one-armed person, would have taken you in certain cases, it would have taken you back to step up one to redefine normal, and then quickly go up through 2 and 3. So,
Yes.
you know, the speed with which you can do that is part of, and doing that quickly, which is what Mr. Cato was on about, is and efficiently is what we really mean by the real meaning of genuine continuous improvement.
Yeah. And two other quick points with it. One was we weren't successful in every endeavor, just depending on
No.
the nature of the fixturing and the
No.
part. We weren't always. But
You were
sometimes-
PDCAing though, weren't you?
Yeah. Oh, absolutely. Sometimes, but we get things somewhat more successful than what they've been previously. So that was a big part of it. We weren't always successful. But the other thing it did, like you said, on the speed, the more we did that, and the more we would share with our colleagues and go see what other people were doing, you just build up this knowledge base, so we could go into a new problem and think it through. In a sense, do the plan, do, check, act cycle much more rapidly and much more successfully.
Yes.
We're starting at a different plane.
Very good, Jim. I know what you like, and I know if I kept going, you'd keep going. We'd talk forever, but we need to cut. We're running very low on time here. So thanks very much, Jim.
All right,
I'm going to go back to sharing my screen. Appreciate that conversation. I'm going to go back to sharing my screen. I've got a couple of slides to go. All right, so you should all be able to see my screen again. I'm on slide 16, where we just had that discussion about genuine continuous improvement. So just an ending thought in terms of lean and what it is. I've got a question to ask. I'll finish with. So for me, lean, I always struggled a little bit with the definition of lean up until about, well, I was saying 2 years. Reality is probably 4 years ago now. You know, people would say it's about waste removal and all this sort of stuff. And it sort of made sense, but sort of didn't. But then I saw this definition. That lean is developing people who can and will learn to solve problems and make improvements daily. So lean is developing people who can and will learn to solve problems and make improvements daily. And that, when it was, I suppose in a lot of sense, that's when the lights come on. Now I can see what this thing lean might be about and can potentially be about. So does this statement fit in with the step-up model was my next question, I guess, that was going on in my mind. Once I had this definition from 4 years ago and I saw the step-up model, you know, it was important to me to see if there was an alignment in my mind for this and to see if I can see it happening. There is. So remember, this is the step-up model. We spoke about getting stability, the first 3 step-ups, and then just spoke with Jim about genuine continuous improvement, where we're striving for new levels of performance. And that paradigm shift he gave of the one-arm person was terrific. Would have driven a lot of improvements. So how does this step-up model fit in with that statement of lean? Well, in my view, it fits in perfectly. Because if you think about it, we're problem solving daily when we're gap closing, and we're making improvements daily when we're gap setting, step up 4 and 5. So we're problem solving daily with steps 2 and 3, step ups 2 and 3, and we're making improvements daily with step ups 4 and 5. So that definition of lean, of developing people who can and will learn to solve problems and make improvements daily, fits in perfectly, I believe, with what you see there. You can see that the problem solving below the green line, improvements daily above the green line. Gap closing, gap setting. All right, so thank you very much for your time in listening to this. I appreciate you giving me the time. But in particular, thanks again. I've had a lot of opportunity for this through Lean Frontiers. I've got a little sign on my wall. I often say it just to the left. It says, if you can't explain it simply, you don't understand it well enough. So I trust that Jim and I have done justice to that statement that's there. So thanks, Lean Frontiers. Thank you, Skylar, for organising this. And thanks, Jim, for that little discussion we had and the build up to that discussion over the last 3 or 4 years. If any of you have any questions, my email address is there, Roche@twainstitute.com, and our website is listed there. So have a great day, and thank you very much.